Well, here we are, part 3 of my Ender 5 linear rails mod. In the first 2 parts, I've disassembled the printer, and I got us to the point where we are today, which is where we have the rails installed. I've got a couple of new end stops installed, and I came up with a makeshift solution on how I was going to guide the belt off of the ends of the rails. In this video, I actually have received the idler wheels that I needed to guide that correctly and get a smooth motion. So without further ado, let's continue on with this mod, and then afterwards I will be able to show you the before and after prints to show you really, does this make a difference? Is this a mod that you want to do yourself, or do we still have a few more steps we need to do to really get this printer where I'm trying to get it? And that's what we're doing today right here on Kris Fabrications. Let's go. So it's been a couple of days and my new idlers have come in. These are GT2 idlers, 20 tooth, which matches the other idler down there. And it is a 5mm bore, so I can use M5 screws with this. So I've spent a little time and I've developed this new idler adapter specifically for this printer. Puts the idler at exactly the right height that it needs for where this belt comes off of here. And let me show you how you put this together. So we take our belt, we have pulled it off of the end here, and then what we're going to do, we put the belt through, and then once we've put the belt through, the idler pops into place. Okay, now it's easy to take an M5 by 20 screw and put that in there. Make sure that at this point that the idler moves freely, and this one does. And then we can go and add the M5 nuts onto here along with either a nylock nut or the lock washer like I have here. And we make sure that the idler still moves freely when we do that, which this one does. And we just want to put it tight enough on there to where the idler does not bind up. Then we can easily take the M3 screw for the T-nut, put that into there. And you're welcome to screw these out, drill these out a little bit if you'd like. Doesn't really matter. They'll work their way out. We add our T-nut back. And then this whole assembly pushes flush up against our rail. And we can tighten this down. Got to make sure that the screw actually goes in there all the way. There we go. Once we tighten that down, this assembly's done. We make sure again that our idler still moves freely. It does. Designed this to actually pinch the idler without binding it. And then, notice this is loose still because we are not going to be able to tighten this until both ends of this rail are done. You have to pull this out a little bit more. And then if we still don't have enough slack, but I think we do. We do. See, there we go. So now this whole assembly moves. Notice the idler is tight, and it puts the rail, I'll give you a side view later, this puts the rail at exactly the right height, and it moves freely. So now I need to remove all of those previous pieces that I had done, these little yellow pieces, and I will replace them with these. Then we can get going with some test prints and make sure everything is moving well. All right, there we go. Let's do a home sequence on this printer and see if everything looks good. All right, so the only thing I saw that was kind of weird is it looks like this idler might be a little bit too close to the switch. So what I'm going to do is very simply take this idler, I'll get in here to it, loosen it up. I'm just going to move it back a touch. I'm going to tighten it back down to make sure that I'm not hitting that end switch. And actually the better way of doing this to make sure that this idler is still flush is actually what I want to do. I want to move the whole rail that way just a couple of millimeters, because that will assure that the way that those idlers were designed, they're supposed to be pushing one side up against a rail. And just to make sure that we don't run into a situation where it rotates or something, I'm going to actually loosen this whole rail and just move it down that way a little bit. I noticed that the other rail seems to be a little bit further down. I'll verify that with a ruler here in a minute to make sure that they're both in the same spot. That kind of alignment doesn't matter a whole lot until you run into a problem. Alright, using my calipers, it looks like this rail is currently, or the end stop, I can do the whole rail. So the rail at this point is about 54 millimeters on this end. On this end, it is 54 to 55. So I just need to move it down a millimeter or two. Slide it a little bit this way. Make sure that the end of it is past the end stop, which literally was just a millimeter or two. And now we'll tighten that back up. Of course, now I just need to also move this one down to be flush up against the rail again. And then I'll move the other one to where it's flush up against the rail. Now the homing should go correct on this one. Let's find out. There we go. No problems. So here it is, the mod in its final form. You're going to have to forgive my camera work a little bit as I show you around. So first of all, here are the idler wheels that I designed. If you'll notice, they move quite smoothly. These have been running for a little bit, but they work really well. The only other mod that I've done since the end of the filming of that last video was I did end up having to add an Y end stop because it wasn't centering on the bed any longer. So now there are new end stops for the X, the Y, and the Z. Those will all be part of the Thingiverse kit or the package that I release with all these models. For a little bit of reference when you're lining all this up yourself, if you'll notice, the Y rail needs to be installed. Let's see where we got here. I'm seeing about 6.5, 62 millimeters, just roughly 62 millimeters from the end. There's going to be a little bit of leeway there one way or the other, but I wanted to give you a little bit of reference. The X rail, though, is going to be centered. And I did have a request to do a mod to these end stops to where they will actually be silent end stops. I may be working on that in the future. Keep an eye out. I'll post on all of my social media if I do that mod. But yeah, that's about it for this one. I think those are all of the relevant pieces that you're looking for. I am actually going to be switching these out. I've reprinted them all to make sure that the models that I am giving you are correct. And I've printed them in some even tougher high temp PLA. Well, now since everything is moving correctly, I think it's time for a test print. Now let's get this camera set back up here and we'll see how it prints. So here I am with my plethora of test prints. I tried to come up with kind of a range of different types of prints. I didn't want to just do one thing or two things or do all of them with the same settings. And so I came up with a bunch of different types with different settings, and let's see what we find. So starting off with the benchies. So both of these were printed on the Ender 5. One is a roller print and one is a rail print. All of these test prints were done with exactly the same G-code. So can you tell which is which? Hopefully the camera is picking up the details on these. I'm going to give you a minute to take a look at them. Get a little bit of gleam and glare. So you may be able to see the bottom of these at this point. So these are printed at 50 millimeter per second. So these are those low and slow prints. And taking a look at it, this is the rollers, this is the rails. Giving you my opinion of them. I notice very little difference in these two prints. I think the rail one is marginally better. But overall, I can tell that these are printed on the same printer with the same G-code. Really no major difference in one over the other. All the same flaws are there, minus this little pimple on the rollers one, but you know, that happens. So overall, no major difference between these two. Moving on, this right here, these are the Maker's Muse tolerance test. I want to know if there's any tolerance difference between running with rails versus running with rollers. And can you tell a difference between these two? So, first thing I'll tell you, let's look which is which. This one's the rollers one, this is the rails one. The only difference I see between the two of these is there seems to be less marring on the top of this one than this one, meaning there's less stress in the plastic. I don't know how the rails would really contribute to that. So this is the first model where I'm really going to tell you what the problem that we're going to run into here. So this is the rollers one. These, oh, by the way, these were printed at 100 millimeters per second in the slicer. Now, of course, that doesn't take into account layer 1 speeds. It doesn't take into account your acceleration and jerk settings. But these were printed at 100 millimeters per second. And let me show you something. This is the rollers one. This is the before one. 0.15 moves. It took a little braking to get it to move because I had some problems with my raft here. But it moves at 0.15 before we did anything. Does it still move at 0.15 after we did something? Sure it does. No change. So again, no major difference between these two prints. Next up, my favorite calibration test, the CaliCat. And again, let's take a look at these two. What do you notice on these? I don't know which is which at this point. Without knowing which is which, I like this one a little bit better. And that's actually the roller one. So what I'm noticing here, there seems to be more waviness in the rails one. There's a little drooping in the extrusion here. But there's still no major difference. While I am noticing a little waviness in this print, there's no real major quality difference. When I look at it in the right light, this one seems to be a bit better, just less layer dipping. But overall, they're still the same print. And they're very good. So these were interesting. I wanted to see what my layer consistency looked like. So I printed these vase mode prints to check layer consistency. These two are printed at 50 millimeters per second, while the two behind were printed at 100 millimeters per second. One thing I did here was, if you look in Cura, there's a setting for minimum layer time. And the minimum layer time setting, make sure that your print is good and cooled before it layers the next layer on top of it. I took that off. I set it to 0, which basically says please print 50 millimeters per second the entire time. So these were printed 50 millimeters per second the whole time. These were printed 100. Again, let's take a look at these two. Do I notice any major difference? So in this one, there's a pretty big flaw here. There's more ringing on this fin than on this fin. There also appears to be more ringing, yeah, a bit more ringing on this one too. Again, I don't know which is which. I haven't looked ahead of time. Other than that, this one has slightly better layer consistency than this one. So I would say overall this is a better print. Let's see which one I chose. Again, that's the roller one. So the before one I choose as a better print. And moving on to the 100 millimeter per second one. Keep in mind, this is going to continue to look worse. One thing I'm going to talk about is that I don't think the cooling is still good at all on that printer. Definitely not good enough to go fast. Because as we see, as we go from 50 millimeter to 100 millimeter, we see major blipping and blobbing because it's not having time to cool before we're layering the next layer on top of it. Anyway, back to the prints. Which one of these is better? Well, no major difference as far as I can see. I might pick this one as a better print, but I'm not sure. As you can see, there are some serious quality issues on both of these prints that are consistent with one another. And that just comes from going too fast, not cooling fast enough. That kind of thing I was talking about. Again, this is the roller one. This is the rail one. No major difference between them. Still think the roller one might be slightly better. And getting away from test prints, let's talk about an actual functional print that I do. This is from a helmet. This is from the Mark III helmet that I did. And one thing you notice on this one, it is a nice gradient here on this curve, which means that we need these layers to be laid down as accurately as possible in order to produce the print that needs the least amount of finishing work. So this is from the rollers. This is one I printed in my other video. This is from the rails. I printed in a different color, same manufacturer of filament, but a different color. And what you'll notice here is what we had seen in one of those earlier test prints, the Calicat print, which is a waviness. I do believe that the layers are more consistent on this one. I do think that they are laying down slightly better, but there's a waviness. There's something being carried over from the printer that that's making it into the print itself. Layers are more consistent, but now we have a new artifact. Again, these are printed with the exact same G code. The only difference is the mod. And finally, a brand new print. Nothing I have for comparison, but something I wanted to show you. This is from a certain gauntlet. This is something that I'm printing. I want it to be as perfect as possible out of the box. And it's beautiful. It is a beautiful, beautiful print. You can see layer differences, but the consistency is really, really good. So what's the difference between this one and this one? Excuse me, this one and this one? Simply that we don't have the long runs that we have on this one. These are long curves, these are long runs of filament, where these don't have to go as far. These aren't going to speed up as much and are going to have to turn before it really picks up speed. So to wrap this up, let's talk about what I think is going on with our test prints and why this mod hasn't turned out to be everything that me and many of you had hoped it would be. Well, first of all, let's talk about one of the problems with the Ender 5. It's too good to begin with. So the Ender 5's motion system and the way that the Ender 5 print does a really, really good job. And as I showed in these prints, the printer is actually very, very good in terms of its accuracy and its precision to begin with. So we're trying to improve on something that is already high quality, and that doesn't leave us much room for improvement. So that's a flaw for the Ender 5? Not really, but it just leaves us less wiggle room, and each of these mods are going to be a little less of an improvement as we get closer to what we might consider a perfect print. Second of all, I'm still using the default mainboard and the default firmware that came with this printer. So what's the problem with that? Well, it's really those stepper drivers that are on that mainboard. What we're running into, I believe, on these prints is we are still seeing a lot of that motor vibration carry over into these prints now that the system is so rigid. So before, those rails, those rollers are made of rubber. It's a hard rubber, but it's still a rubber, which means that it's going to absorb some of the vibration and keep it from getting into your prints. Now that we've gone extremely rigid, that vibration, I believe, is making it into our prints and making it more difficult for us to see improvements on some of these test cases. So that means that either number one, we need to install some dampeners on those motors, or number two, which is what I'm going to do, is replace that board altogether. And finally, the last problem, which we saw on these guys, is that the printer does not have sufficient cooling to go at speed. If we keep it around 50, 60, maybe even 80 millimeters per second, if we keep our minimum layer time, what we're going to do is we're going to see that it has time to cool. But if we really want to go fast, or if we want like super precision because we're going to be doing overhangs or really intense curves, then we're going to have to add more cooling. So that's going to be a mod I'm going to work on as well. Well, I hope you've enjoyed this series. I hope that you've learned something from it, either from my engineering or from the test prints and what I've actually been able to show you here. As you can see, we're not done with this printer. I'm going to leave my mod on there. I'm actually going to work on now improving those two things that I really want to see what it does. I'm going to be replacing the mainboard with the new 114 mainboard from Creality, which has the TMC 2208 steppers on it. Then I'm also going to start designing a new cooler for it. I know that there are some out there. I know that there are some that came from the Ender 3 world, but I'm going to see what I can do on my own to produce a quiet and high performance cooler for the Ender 5. Thank you for joining me. If you have enjoyed these videos, please give me a like. Please watch the other videos on my channel. If you haven't subscribed, what are you waiting for? Hit that subscribe button. Hit the bell icon so that you get notified when I post new videos. If you want to support this channel, I've included the Amazon affiliate links to everything that you'll need to make this mod for yourself, as well as the Thingiverse links for you to print this mod for yourself. Other ways of supporting me, I have a Patreon, I have a PayPal link. Thank you for all your time that you've devoted to these videos. Thank you for all of your feedback in the comments. I read every comment. I usually actually respond to almost every comment. So again, thank you for joining me. I'm Chris. This has been Kersey Fabrications.